Okay. All right, good afternoon. My name's Frank Sturek. I work for Pratt Miller Engineering. Small business out of Michigan. Primarily, our core business is motorsports. We design, develop, build, test, and race race cars for General Motors. We're exclusive to them. So we also have a defense business, and in that we've worked on the TECD program for occupant-centric design that supports TARDEC, a research project for occupant-centric platforms. And through this program, where we're the prime contractor or integrator for this TARDEC program, we found this challenge that, in looking at soldier survivability, we found that most of the combat fatalities and injuries occur because of improper wear of restraints or soldiers not wearing restraints. In fact, there was a study that was done through the Army Safety Center, or sponsored by the Army Safety Center, where 40% of soldier fatalities could be reduced by proper wear of restraints. And that's for rollovers. The study was done, but it also applies to blast and collisions. Another issue that we found through the research was that soldiers commonly avoid wearing restraints. They have bulky gear, so 5-point harnesses aren't really conducive to operating in a tactical vehicle, especially a combat vehicle, but also tactical vehicles. And then the other part is you look at the problem as if you are completely restrained and can't get out if a incident happens. So that's where the initiative for a quick knife to cut yourself out of a restraint when you had a rollover or an accident came from. So with that, through the research, we found out that just a couple of things. Soldiers don't wear restraints. They don't want to wear restraints, even though there's a lot of command emphasis on wearing restraints in combat. So through our additional research that we found in blast events, where if you're not restrained, you tend to fly inside the vehicle and cause more injuries. We started looking at the problem of restraints and how can you make them so soldiers want to wear them. So that's the challenge. How do you get soldiers to wear restraints? How do they want to wear them? And how are they seen as value added to their mission and also their survivability? So with that, TARDEC sponsored a small business innovative research. We're in phase 2 right now. And the articles you see in front of you is the first article that's been produced. It's called Hackers, which is the hands-free automatic coupling restraint system. Next slide. So like I said, this is really, through the research and the initial study, we found that there were 3 problems. 1, accommodation. The restraints don't fit the soldier population. The 5th percentile and the 95th percentile a restraint system is totally different, so it has to be adjustable. Most of the systems aren't that adjustable. The next one is containment. So how do you keep them from properly being seated or properly being restrained in the seat? So a 5-point can do some of the things, but for different events, they're not very effective. And then I mentioned usability. So one is the ease of putting it on. If you have gear on, so this, how do you adjust the 5 points so it accommodates the gear when you're wearing, when you get your ammo pouches, you've got all your different devices up front, wearing it on the front of your body armor. The other part is it easy to take on and off and easy to adjust? And then does it fit the different, not every soldier wears the gear the same way, so you can't, there's always an emphasis to do that, but that doesn't usually happen. So you have to have something that's flexible. So these are the 3 main reasons that soldiers don't wear their restraints or they're not effective. So I'm going to turn it over to Kellen Evans, and he's the lead engineer for this program, or the chief engineer, and he's going to talk through the process and the solution.
Next slide, please. So Pratt & Miller's been spending a lot of time on this. We've spent 2 years working with TARDEC trying to figure out how to make a better seatbelt. So seatbelts, in essence, work very well at holding people. But they have these 3 main problems that Frank mentioned. So what we did is we started with brainstorming. We said, what could we do? Could we Velcro them on? Could we use magnetic pulses to hold them in place? What is out there that can do this? What other industries? Body harnesses are an example of something that works in other industries, but doesn't necessarily work for the soldier. And then we did a trade study. We put all this together and we said, if we could build the perfect system, what would that system look like? And through all that, we started designing it, developing it, doing excessive FEA analysis and simulation in order to figure out how do you actually solve this problem and make it useful for the soldiers. And then also a lot of user juries. What does the soldier actually want? What does he need? Next slide, please. So as Hank mentioned, the 3 problems, we feel we're addressing all 3. Hackers is a hands-free automated coupled restraint system. It's designed to accommodate the soldier population. It's designed to be fast, effective, usable, and it's designed to contain them, to do what the purpose of a restraint is mostly to do. Next slide, please. So I'm going to talk a little about each one of these in a little more brief. So accommodation, soldiers are very large to very small. They have different gear sets on them. And if you try to put a typical belted solution on, you have to either run it through your gear or you have to put it over your gear. So we said if we're going to a system that's going to automatically deploy the system on you, it has to do it and still accommodate that range of soldier and population. So we designed it a bar system that could come down, but could be asymmetrical. So if you had gear on one side of your chest and not the other, it would still contain you and it would wrap on that gear. If you were very large, you'd still fit in it. It wouldn't be like an amusement park ride where it's crushing you down in there if you're tall and not holding you very well if you're small. And it would be designed to allow them to move. So like most hard systems, we needed the ability for the soldier to move while restrained and be able to lean forward and pick something up or talk to his buddy or hold his weapon. Next slide, please. And it has to do all that and still contain you. It still has to be able to hold you. So our system provides superior containability. In frontal crash, blast, underbelly, rollover, side impacts, it keeps you in that seat and it holds you in there. Because it's a combination of a hard system that acts as a load limiter stop, but it also has belts to accommodate the different size. So we can stage the pulse, we can keep you in there, and we can protect the soldier. Next slide, please. And fundamental usability. So it doesn't matter how good the system is, if the soldier is not willing to use it or forced to use it, it's not going to do its job. So this system is designed to maximize usability. It's an automated system. The commander can flip a switch and all of these systems will automatically deploy onto the different crew. He can flip another switch and he can release all of them. Or the soldier can grab the arm and he can pull it down himself. If he's injured, he can pull it down with one hand. He can use a body part. For release, he can release it manually. It can be released automatically. Or an emergency, because you can't cut through this very well unless you got a lot of time, it also has an emergency pin release. You can pull a pin and release the system. So if the soldier is injured, the vehicle's on its side, it's in water, and someone goes in there to get him out, he can pull a pin, the system drops away, and he can get him out quickly. And all of that while containing and protecting him. So not only is it designed for usability, and Steve will demonstrate how quick the system works, but it's in and out. There's no 20 seconds, 30 seconds, assembling a 5-point. It is on, it is off, it is done. Probably done that once or twice. You notice it has asymmetrical bars. That's not only so that it can adjust each side independently, but also clears your helmet, any night vision goggles, or any equipment you may be wearing. So with this simple application right now, in rollover, crash, blast, frontal, side collision, he is now protected from every event. It is designed for the soldier. It's designed for someone with an IOTV. It's designed for someone with a helmet. It's designed for short people and tall people. Thank you for volunteering. It's also designed for different markets. If you flip to the next slide, please. Thank you. So it's designed for infantry carriers, combat vehicles, rotorcraft. It's designed for any vehicle in the military. It is also designed for commercial applications as well, but it's designed to fit, it's designed to be quick, it's designed to be easy, and most of all, it's designed to save their lives. So with that, I'm going to turn it back over to Frank, kind of talk about our next steps.
Thanks. Okay, next slide. So right now, this is integrated into a mid-end seat, which was the seat that we were using for our occupant-centric platform demonstrator called Camel that we used and was in our program. What we're looking for is we're looking for different applications. So if I look at the current fielded systems, if you go over there and you look at the Stryker ECP, you see that they have a certain seat in there, and it has a 5-point harness in it. This, we could get a application designed specifically for the Stryker systems. And you can imagine Stryker soldiers, infantry combat soldiers, would be wearing all their gear, and so just concentrate on the tusks and that integration of seating. We also have the ability to make this automatic. So once you would get in, if you could run it through the power, that's one of the other variants. You could have run it through the power of the vehicle, and the squad leader could control actuating, open them up, or making sure that they're all down. And then you could still, as an individual soldier, still activate and release. But that gives, there's always the one thing, as everybody belted in, you're sitting in the back of a combat vehicle, you certainly can't look all around to figure that out, but then the squad leader would know if he activated those to bring them down. So there's a couple there. You got the Stryker, you got the AMP-V, you got existing helicopters. Another one of the things is getting on and off of helicopters. Crew chief wants to know everybody's in. Once everybody's seated, crew chief presses a button. You can make the tusks smaller so they can get in, and it curls right on around, and everybody's belted. Anybody that's gotten on and off a helicopter with seats in knows it's not so hard getting out. It's always the pain in the rear of getting in, and then the crew chief coming over and helping you and getting your stuff hooked up, especially if you're all amped up from running off somewhere and getting on a helicopter and trying to get out on an air assault. Our first responders. It's tragic, but a lot of firemen get injured because they're not wearing seatbelts when they're going through, and somebody doesn't get out of the way and they have an accident. So this would be a quick way to do that, and they can get quickly out. On new starts, we're looking obviously in the combat vehicle program. We're looking at AMP-V as another one, as a possibility, or AAV, the amphibious combat vehicle. So one of the things that we have a great relationship with the state of Michigan. Michigan is looking to match any of the funding that we can get from another use case or a private company that would want to implement this into their use case, and then we would actually get matching funds from the state of Michigan that can help defray some of the costs for development for your specific use case. So once we finish phase 2, which we'll have several articles that we'll develop, and we'll actually go through the testing, because all of our testing has been modeling and simulation. We'll go through user juries, and then finish phase 2, and then hopefully go to phase 3, where we'll go to production and commercialization, where we'll start to go into design for manufacturing, reducing cost, and figuring out the exact use cases where we can produce this. So with that, are there any questions? Yes, sir.
Sir, for the side impact, what is going to restrain the person if there's IED, has a lateral blast? Is it going to be your neck that stops you? I mean, what is going to stop the bottom portion of the body?
I'll take this one. So part of that it depends on the vehicle architecture. So if you're in a Humvee, the door is actually stopping you to some extent. And the back of a Stryker, because you're stuck in other seats, you would also have a side bolster in order to help. It's not actually your neck that's stopping you, although it looks like it. It's the belt that's slowing you down. So the first thing you'll go run into is the belt. It will slow down your impact. Side of your body will hit, your shoulder will hit, and that will keep you in the vehicle. So it does depend when you get in to decide what type of vehicle you're in, what your mitigation has to be. Now, in a 5-point system, your neck's also stopping you. You go out of the seat sideways, and your neck gets stopped by the upper belt, and it swings around. So this does something similar, but it adds another layer to it to try to help protect you.
Yes, sir. In a 5-point system, of course, you've got 2 around the bottom half of your torso. And if you're in an M-wrap, which doesn't have anything on to your left
Yep.
and your right side, that was my concern.
Yeah, so you'd have, what's not shown on this seat is you'd have a lower bolster off the side that's holding your hips from that side motion. So that's not on this particular seat, but that's really what would replace that lower hip belt.
I guess the only thing I would add is use case dependent. So the concept, the technology of the hands-free automated system can be applied differently depending on what type of vehicle it is and what type of seat that you want. And that's the flexibility there. It's not designed just for this. We're not going to take this mid-end seat and try to shove it into something else. It would be modeled and simulated to maximize the protection for the soldier. Any other questions? Okay, thank you very much.
Thank you, Frank.